Okay, welcome to today's lesson in further mathematics. I want us to consider, still in the line of what we've been discussing the past few weeks, I'd like us to move further into discussing further on the remainders theorem in polynomials. Now, what is remainders theorem? When we talk about polynomial and its division, we considered some factors. The first time we talked about the divisor, we talked about the dividend, we talked about the quotient, and we talked about the remainder. Now, the remainder theorem is what we'll be laying more emphasis on. I told you the other day that the equation that is dividing is called the dividend, and whatever thing you're dividing it with is called the divisor, and the answer is a quotient, while the remainder is what is left after the dividend is being divided by the divisor. Having this answer, the remainder is this. Now, we can go further into getting this. Let's do a recap of what actually happened. Let's divide this. 2x3 minus 3x squared plus 4x minus 1. Let's divide it by x minus 1. Now, when we have something like this, I told us in our previous class that we start by saying 2x3 minus 3x squared plus 4x minus 1. Now, this is where you play the divisor, x minus 1. So 2x3 divided by x, the x term, you have 2x2. 2x2 times x is 2x3. Now 2x2 times 1, you have minus 2x2. You bring down your line, this minus this, so this is off. You have your minus 1, you have your plus 4. This minus this is minus x squared. So minus x squared divided by this is minus x, and minus x times this is minus x squared, and minus times this is plus, okay, this 4x is plus x. You perform another this by putting a minus sign. This minus this minus this will give you plus. It goes off. You now have 4x minus x is 3x minus 1. You go further in the division. 3x divided by this will now give you plus 3. 3 times x is 3x, and 3 times minus 1 will give you minus 3. When you cover it, this goes off because of the minus sign, and minus this minus 1 plus 3, because this minus minus is equal to 2. Now, when you do this, this is the remainder. This is the dividend. So this is the dividend, and this is our divisor, and this is the quotient. So the essence of this remainders theorem is to tell us how to get the remainder when this dividend is being divided by this without passing through all this process. Now, the analysis goes this way. If you have like the question we just solved, 2x3 minus 3x squared plus 4x minus 1. Remember, this is the fx value. Is this. Now, they are now telling you that divide by x minus 1. And remember that this x minus 1 is equals 0. So what you need to do now is to get the value of x. That's what remainder theorem is telling us. And for you to get the value of x, minus 1 will come over to this side. So x is equals 1. Now, if you put x as 1 into this equation, the answer, whatever answer you get, becomes the remainder. So let's try it. Fx, f1 becomes 2 1 raised to the power 3 minus 3 1 raised to the power 2 plus 4 1 minus 1. Now this is 2 minus 3 plus 4 minus 1. 2 minus 3 is minus 1 plus 4 minus 1. So minus 1 minus 1 is 4 minus 2, which is equal to 2. Now the remainder, if this is divided by this, the remainder is plus 2. And this was the same answer we got while we solved our formal question. Now I would like us to apply this in solving more questions subsequent time. Now let's solve this other question. So find the remainder. Find the remainder when x cubed plus 2x cubed minus 4x plus 3 divides x plus 1 divides x plus 2 and finally x minus 1. What will be the remainder? Now let's solve. Remember what I told you. This is fx. Now let's start from number 1. Remember we say it's dividing x plus 1. So what we need to do now is x is equals minus 1. So we put x as minus 1 in this expression. So let's deal with x minus 1, which is minus 1 raised to the power 3 plus 2 times minus 1 raised to the power 3 minus 4. This is minus 1 plus 3. So we go further. Minus 1 raised to the power 3 is minus 1. Then minus 1 raised to the power 3 is still minus 1 times 2 is minus 2. Minus 4 times minus 4 times minus 1 is plus 4. Then we now have plus 3. So 4 plus 3 is 7. 7 minus 3. 7 minus 3 is 4. So if this is being divided by this, the remainder will be 4. Now let's go to number 2. Number 2. Let's take it. The function there is x plus 2. So remember it's equals 0. So our value of x is equal to minus 2, because when you bring this side. Now apply minus 2 into this expression. You have x raised to the power 3 plus 2x 3 minus 4x plus 3. So we now have minus 2 raised to the power 3 plus 2, then minus 2 raised to the power 3 minus 4, then minus 2 in bracket, then you now have plus 3. So minus 2 raised to the power 3 is minus 8, and minus 2 raised to the power 3 again is minus 8 times 2, which is minus 16, minus 4 times this will give you plus 8, then plus 3. Plus 8 goes with this, so minus 16 plus 3 is equal to minus 13. So if this dividend is being divided by this, the remainder will be minus 13. Now let's do for the last one. Remember our fx, always learn how to note it down, is equals x free plus 2x free minus 4x plus 3 plus 3. Then we are dividing it by x minus 1. So with this, if we are dealing with x minus 1 equals 0, so our value for x will be 1 because minus 1 comes to this side and x is 1. Now let's solve for f1, which is 1 raised to the power 3 plus 2 1 raised to the power 3 minus 4, we have 1 plus 3. So 1 raised to the power 3 is 1. 1 raised to the power 3 again is 1 times 2 is 2 minus 4 plus 3. Now 1 plus 2 is 3 plus 3 is 6 minus 4 is equal to 2. So when this divides this, the remainder is equals 2. Now you can see that this one has actually helped us in analyzing this very fast instead of going through the long division method. And I think with this easy step, you'll be able to tackle whatever question that comes up in Remender's theorem in subsequent time. So in order for you to refresh your memory on what we've just discussed, take the test that will be appearing shortly on your screen, and also do well to use the lesson notes on the platform for better information on the topic we've discussed. Always feel free to drop your questions on the comment section. So thank you. See you in our next class.